My name is Aryan Hamid. In this video, I'll talk about the data engineering pipeline that I've used in my internship project and how it can convert something that is totally raw into something that is totally usable and special and can be used to gain useful, major, small, all sorts of insights about a business or anything that you want to get deep into. And in this video, I'll also quickly talk about the basics of data engineering, what data engineering actually is, ETL, and etc., and the tech stack, that is the secret sauce, and why they are the MVPs for this operation. And meanwhile, I'll also throw in a real-time example with the sample dataset to showcase how exactly my pipeline is working. I'll go a little bit in depth in the pipeline, and towards the very end, I'll show you how I have leveraged this pipeline into my actual internship project with the real dataset. So let's get started. So what exactly is data engineering? Well, as you can understand by the term itself, that it is the engineering of data. It is indeed that simple. But if you want to understand it in more depth, this is how I understood it. Let's assume 2 points, point A and point B. Now, your point A can be the storage of your raw data, which can be your databases, your warehouses, or any other API that can be used to fetch raw data from a different source, like your IoT devices or anything. And your point B can be your dashboards or any other platform that you can use to visualize your data and get important insights from it. So in order to be able to upscale your business, or in order to make the right use of data and consume the power of data, you need to make sure that the raw data is clean and properly usable. And you also want to make sure that the entire process is automated, because whenever you get a new update in your data, let's say you have an IoT device that is measuring some noise, that is measuring the noise metrics in a city or just outside your house. It is auto-updating and it is sending new rows of data after each hour. So you cannot just sit there and clean the data every time on your own. You need to make sure that the entire process is automated, and whenever the IoT device pushes a new noise metric data into your storage, it should go through a pipeline where it should be properly cleaned and transformed and baptized. And it should be automatically be able to be visualized, and so that you can see it, and all you have to do is understand the visualizations and make important decisions whether you should leave the city that you are staying or just change your house to a more silent location. So I hope you understood that. That's pretty much what data engineering actually is. Also, one major thing to add is that this process of extracting the data from your surroundings or from your sources and then transforming it in the pipeline, that includes transformation and cleaning of the data, and then just loading it into your dashboards or any other visualization program, is also known as ETL. It stands for extract, transform, and load. And ETL makes up the fundamentals of data engineering. That's pretty much what data engineering actually is. So what we have in front of us right now is a sample flowchart of the sample pipeline that I'm going to be creating in my hands-on practical a little while later. Starting with step 1, data from CRM and other sources. The other sources can include APIs, the IoT devices that I was talking about. You can just assume it as point A that I was speaking about a little while earlier. And then from step 1, you go to step 2, data in Excel. Well, the main crux of this step is to visualize the data into a tabular format or just a structured columns and rows format. I'm gonna go ahead with an Excel worksheet because this is the format in which I received my internship data basically. Otherwise, you can also use SQL tables or any other storage platform that can help you visualize the data into a tabular format. Why do you need to visualize it in a tabular format though? You need to do that so that you can have a clear eagle eye on where you need to perform cleaning actions on a data set, where you need to perform transformation in the data set, and other feature engineering techniques that you might want to apply. And from there, I am maintaining a Docker container. The reason why I am maintaining a Docker container is because I didn't want my code to be restricted to a specific operating system. I wanted it to be compatible with all sorts of environment, that is Mac OS, Linux, or Windows. And then from step 2, also, yeah, I'll be talking about the Docker images and the specific images, the Apache Airflow images that I have used in my project. Yeah, so from step 2, we go to step 3, Apache Airflow. Well, Apache Airflow is just an orchestration platform that can help you schedule tasks in a given interval of time. And what is a DAG? Or just simply DAG? It stands for Directed Acrylic Glass, and I'll break it down into simpler forms. So the keyword here, directed, it means going in a forward manner or a forward fashion. For example, from A, you're going to B, from B, you're going to C. You're going forward from A to B and from B to C. That is, once a specific task, that is task A is completed, you're going to task B. And when task B is completed, you're going to task C. And what does acrylic here mean? Acrylic here doesn't mean something that is plastic or something that is artificial. What it means here is that you cannot go back into loops. Like for example, from task A, you're going to task B, from task B, you're going to task C, but you cannot come back. You cannot come back, like you cannot go task C to task B after completing task B to task C. It's just that you cannot go into a circular fashion. And it just avoids the formation of a loop, and it gives you a hierarchy of what needs to be done after what. And that's why I am using Apache Airflow here. And as I code in the later stages, the DAG will be targeted to a Python function that will be cleaning the sample data that I'll be using. And once the data is cleaned and all the specific and necessary actions are performed on the data, it will directly go into Azure Data Lake Gen 2. A data lake is just a centralized repository for storing all sorts of your unstructured and structured data together. And from there, I'll generate a URL. More specifically, I'll generate a SAS, that stands for Shared Access. Forgot the full form of SAS, never mind. And from SAS, here, the SAS link, you'll be pasting that link into your dashboard. And voila, you have a real-time pipeline established. So let's say, again with the former example of the noise metric system that I talked about. Let's say the IoT device has pushed some new data into the storage server that we're using. From there, it will go into an Excel format. And since I've already created the code, I will have already created the code for cleaning and everything. We don't necessarily need to look into this step. Now, let's say I have established my DAGs to run in an interval of 1 minute. So after each 1 minute, my code will be rerun, and the sheet will be cleaned again, and the new data that has been pushed by the IoT device into my storage, it will show up in the new data, the new clean data. And the new clean data will again go to the Azure Data Lake Gen 2, and the already set up SAS URL will communicate with the Data Lake Gen 2 server. And once I go into my dashboard and click on refresh, the new data or the updated data will show up. Okay, let's start with the coding part now. So to begin with, I'm recording this video towards the very end because this specific part got deleted somehow. And that's why you can see some extra stuff here, data refinery, SRK, cleaning, but we'll be going and covering those codes also in the later stages of this video. So anyways, focusing on the point, what exactly is a Docker Compose file? Well, Docker Compose file is just a set of rules that are needed to build or to start a specific Docker instance. And to understand this in more depth, I'll explain from line 1 to line 33. Yeah, because the rest of it is just very similar to this part. Anyways, so what is a service? The service argument, it just tells us what exactly needs to be present inside the Docker container, Docker instance, I mean. For example, web server, the Postgres, and the scheduler, all of these three are services. And each service is a unique container inside a Docker instance. And 1 second, yeah. So, and then we have the image argument. So the image argument tells us what image do the Docker module needs to use in order to build that specific service inside the Docker instance. So for a web server, we are using Apache Airflow 2.6.0 Python 3.9 image, and then we have the command argument. So you can just think of it as a person's name. For example, my name is Aryan. So if someone wants to call me or if someone wants to talk to me, they're going to call me by my name, Aryan. But and similarly, in this case, if a process needs to use the web server service, they will call the service by its name. That is web server here. Then we have the entry point.sh file. The argument, and this argument is the most important argument because the entry point.sh is a shebang file, and it sets up the prerequisites that are needed for the Docker containers to build and to work smoothly. And where is it? Yeah. So entry point.sh file just downloads and installs all the necessary requirements, all the necessary Python requirements inside the Docker container, and it also initializes the Postgres database for our web server and the scheduler services. And in the next argument, we have depends on. So it's very self-explanatory. For example, this web server has its depends on argument set to Postgres. So basically what it is trying to say is that the web server service depends on the Postgres service. If the Postgres service exits out, so will the web server service. And if the Postgres service is working fine, the web server service will also work like a charm. And then we have a few environment variables, then a few logging arguments as well. The max size, 10 MB just tells us the max size of the log files, and the max file should be 3 because I have set it as 3 so that the maximum number of log files generated in one run is just 3, and if it exceeds the number, the last files will be rotated out. And then we have the volumes. This is also very important. The directory that you see on the left of the colon needs to be present on your host machine, because that's how the Docker instance will board the let's say we have a DAG folder here. We need to mention the DAG folder properly here so that the Docker instance knows what to board or what to build inside the Docker containers. So we have the DAG folder here, and then we have the script.entrypointer.sh folder. That is at this folder, and the requirements.txt, we have created the requirements.txt here. And the data folder, well, the data folder is not necessary for our project, but we still keep it so that if there is a need, the Docker container can use it as a cache dumping folder. And then we have the pipelines folder. So inside the pipelines folder, we have the data refinery.py file, and it is the house for all the cleaning functions that we have to write in the later part of this video. And then we have the ports. So the ports argument just tells us that, okay, you need to go to this port to communicate to this specific service. For example, the port for the way to communicate with the web server service would be localhost 8079. This is the port number where the web server UI will be visible to us. Then we have a health check argument. So it just keeps a check on how the specific service is performing, if it has exited out, or if it is working fine, or if it is just healthy. And then we have the networks argument. So the networks argument just tells us how the services inside the Docker instance should communicate with each other. So we have just used one network for all our services. Okay, so now we'll start with the coding part. To begin with, I have set up the prerequisites. That includes the virtual environment, the holy grail, and other than that, I've also installed a few important libraries inside the virtual environment. That includes Python, Pandas, NumPy, and Apache Airflow for now. And I'll also add a few more other libraries as we go on with the practical. So before starting to code, let's take a look at our Docker file. And in the last portion of this video, I talked about how important the directory on the left side of the colon is to our project. So we don't need to create the DAG folder right now. We'll create it later. The script folder, we already have it, and it contains the entry point.sh file. And the requirements.txt file, we'll create it a little while later as well. And data folder, well, it's not necessary for our project, but sometimes a Docker container might use it as a case dumping folder, and then the pipelines directory. So let's just start with the pipelines directory first. And inside the pipelines directory, we'll create our data refinery.py file. And this data refinery.py file will be the hub for our data cleaning functions. So let's just quickly import the necessary dependencies. And then we'll create a function. Let's call it def data clean. We'll pass in two arguments. Let's call it file path, and it will be a string, and then an output path. There will also be a string, and this function will return null. And then let's just create a data frame, and it will be a simple page.csv, and we pass in the file path argument. And then what do we have to do in the data cleaning process? Yeah, so our dataset has a few null values here. And what else we can do is we can titleize everything. What I mean by that is, so for example, we have the string as 0. So we can convert the small z to a capital Z, and we can do the same with the description, and then the same with the directors column. So let's do that. For that, we'll create an anonymous function. By now. The text and maybe title. If is instance, that means if X is a string, it's at that. And if it is not, we'll return X itself. So what this line of code is doing is, if I stare at it, what is here? Okay, so what actually is happening in this line of code is we are applying a specific Lambda function to the entire dataset. And inside the Lambda function, we are passing each rows, and the values of each rows are getting stored in the X variable. And X is getting titleized. That is, if X is a string. For example, if 0 is a string, which it is, it will become capital Z ERO. And same will be happening with the descriptions column. But in the ratings column, since 5.2 is not a string, it will just return the X variable as it is. And similarly, it will do the if instance function in the directors column. Now let's just let's just drop the null values. Now that is done, so we'll just omit the file into the output path. We'll set the index to false. Okay, so now that is sorted, and now we need to create the header URL and the interaction code for communicating with the Azure Data Lake Gen 2 folder. The container. So to do that, we'll go to Azure. I have the Azure portal opened up here, and we'll quickly create a new storage account. And we'll also create a new resource group for this. Let's call it tutorial sample RG. And we'll call the storage account as tutorial SA. We don't need to configure any other headings, so we'll just go ahead and review it and then create it. Okay, now that the deployment is completed, we'll go to the resource. And inside the resource, we'll create a new container. Let's call it tutorial container. Click on create. And from here, we'll copy the access key to this container. Now that the deployment is completed, we'll go to the resource section. And inside the resource section, we'll create a new container. We'll call it tutorial container and then click on create. Now we'll go ahead and copy the access key. Now inside our code, we need to set up a few variables. Our account name was tutorial SA. We need to store the account key as well. And we need to signify the container name. That was tutorial container. And then we'll give our output file a blob name. And with this blob name, it will be stored in the Azure Data Lake. Let's call it clean sample.csv. And now we need to make use of the Azure SDK package. Quickly install it. I've already installed it. We need to import it here. Blob service client. Yeah. Now, blob service client is a class inside the Azure SDK, and it is helpful for creating the header URL to communicate with the Azure Data Lake Gen 2. In our case, we'll go ahead and create a new variable. Let's call it blob service client. And then we'll call the class blob service client. And inside it, we'll create a new account URL key, a new variable, and initialize an F string. And it will be HTTPS, the account name, blob first.net, and then we'll pass on the credentials. Now, this is our header URL, which will be used to communicate with the Azure Data Lake Gen 2. Client. Now, this code is used to interact with the specific blob inside the container. In our case, it will be clean sample.csv. Now, we just need to upload this specific blob inside the container. And to do that, we'll open file from the output path. In read mode, and then speed out. And then we'll just upload the blob. We'll set the override as true because we will be scheduling this task multiple times in a day. So override needs to be true. If it was false, it won't auto update and it won't update the file present in the Azure container. And then we'll just print a confirmation message. Yeah, that's pretty much it for the cleaning function. Okay, now that our data refinery file is completed and the data clean function looks good, we'll proceed with the next folder. That was our DAG folder. Let's just cross-check our Docker Compose file real quick. It's capital DAG. So let's start by making the DAG folder. And inside this folder, we'll create a new Python file. Let's call it main.py. So this main.py file will be the control center or the hub where we will be storing all of our DAGs. And in our case, we'll just create one DAG. And in this file, we'll also determine and signify the configurations and how many retries you want if you want them, and who is the owner of the DAG and etc. So let's start with it. And before all of that, we need to target pipeline tutorial as the parent folder. And the main reason to do that is because Docker will understand only a specific path. And also we need to be able to import these datasets into this file specifically, so that then we can pass the parameters to this data refinery file. So to do that, quickly import sys and OS. Then we'll import sys.pattern.insert. And then we'll set the index to 0 because we are writing this code for parent directory. Then so what actually is happening in this code is first we read the directory, we read the directory of this current file, that is main.py, and then we convert it to absolute path, and then we go one step ahead. One step up, and we set the directory to be DAG, and then after that we go one more step ahead or top, and then we set the parent directory as pipeline tutorial. And after that, we can import our Apache Airflow. We need to import DAG from Airflow. So we'll write on Airflow import DAG. And let me quickly build a path for our dataset and the output path for a clean dataset. So for that, we can set a base directory. And this will be our current working directory. So what this code will do is it will store the current working directory that is so the current working directory, that is user SQL developer pipeline tutorial DAG. So that's the current working directory for this main.py file. And then we can create a file path. Let me just quickly move to this RC folder into our DAG folder. And then you can go like join base directory, join it with the src folder. Inside the src folder, src.csv. Well, actually, we are currently we're gonna run this code in a Docker container. So let me also add DAGs. Because this entire directory will be coded onto the Docker container, and there, this folder will be called as DAGs. Okay. And then let's do the same with the output path. We'll just call it SRK15 content. Okay. Now can proceed with creating the DAG. Okay, before that we need to create the configurations, like the owner of the DAG and everything. So we'll call it config. Let's just call it commandments. And curly bracket. And we'll set the owner. We'll call the owner as dummy owner for now. And we'll set the number of retries to be 2024. 8 is 20. Okay. Then we'll set the capture as false. Okay. Now I'll create a dummy function. Let's call it def cleaning, and it will take no parameters, and it will return none. Then inside this function, we'll call in the data clean function from a data refinery file. So for that, we'll write from pipelines dot data refinery import data clean, and we'll call the data clean function inside the cleaning data function. Data clean, and we'll pass in the arguments of file path and output path here. Okay, now we need to create a Python operator. So for that, quickly from Airflow operators, Python operator. Python operator. Okay, now we'll create a new variable. Let's call it clean operator, smooth operator actually. And Python operator, and we'll give it a task ID of operator. We'll create the Python callable for this cleaning data function. We'll call the cleaning data function in this Python callable variable. So a Python operator is just used for Python files basically, and there are multiple types of operators. There are bash operator for bash.sh and .csh etc. files, and there is a patch operator as well for Windows pack files. But in our case, since we are doing a project in Python and we don't have any other bash or pack files, we'll be using the Python operator. And let's set the DAG as main DAG. Okay, now that is set. So what we need to do is we will quickly Docker compose everything. Okay, we forgot one thing. I forgot to create a requirements.txt file. So that's why it has created a empty directory for that instead. So we'll quickly do that. Freeze requirements.txt. Now that we have the requirements.txt, we'll compose a Docker file again. Okay, yeah. Let me go ahead and delete it. Also, I've already pulled the main Docker images so that the installation is quick. Run Docker compose again. Yeah, it worked fine. Now it will quickly go through the requirements.txt file and install all the requirements that are set in the file into the Docker containers. It's gonna take some time, so I'll skip this process now. Okay, it looks like we faced a small error here. Let's go take a look at the error. It says no matching distribution found for NumPy 1.0. Okay. We will downgrade our NumPy version then. Okay, now that we have downgraded our version, our NumPy version from 2.1.0 to 2.0.1, we'll rerun the Docker command again. And I have the Docker images pre-installed on my system because it would take a lot of time if I were to install it from scratch. So now we'll just directly go into the pipeline tutorial container. And here we see that all the containers, the web server, the Postgres, the web server, and the scheduler are running fine. So now we'll go to the localhost 8079 port number to get an access to the Airflow UI. And here we see our DAG, the DAG that we created, the main DAG, that is. And we also see the dummy owner that we set as. So now to start the automation process, what we have to do is we have to click on trigger DAG. And once we click on trigger DAG, the scheduler will start and it will call the Python function that we have created here at an interval of 1 minute. So, and this cleaning data function will call the data clean function from data refinery pipe. So let's do that. And we have the srt clean.csv file. The dark green color shows us that it was a success. So, and it also tells us that the data refinery, the data clean function ran successfully, and the blob also got uploaded in the Azure container. So we'll go take a look into that. As you can see, we have the clean sample.csv file here, and this file will be overwritten at an interval of 1 minute every time. And if there is any change in the main dataset, it will get cleaned in the pipeline and it will be uploaded here. And from here, what we can do is we can generate a SAS URL, and then we can use that URL to create a visualization on a Power BI dashboard. Let's set the expiration to September 2, then generate SAS token. We'll copy the URL, and then I'll quickly switch my laptop because my Power BI works on my Windows system only. Okay, I switched my laptop to my Windows laptop, but unfortunately on my Windows laptop, the camera gave up on me. So we'll just stick with this. Right now I have a blank report open in front of me. And from here, I'll click on get data from another source. I'll quickly type in web. Once the web UI shows up, I'll copy paste the link that we got from the Azure container for the specific blob. We'll load the dataset. And once we have the dataset, we will create a pipeline. So what I want to do with this dataset for now is I want to show the top 5 movies name with respect to the ratings. To do that, I'll select the movie name and the rating columns. And now we have all the movies named in front of us based on their rating. But I want to narrow it down. So to do that, I'll put a filter. I'll change the filter type to top N and put the value as 5, and then drag and drop the movie's name in the values section, and then click on apply filter. Now, as you can see, we have the top 5 movies named based on their ratings. But now I want to verify if our pipeline is working perfectly or not. So to do that, I will click on the movie 0, and currently, as you can see, the rating is set to 9.2. And I'll quickly go back to my other laptop and change the raw data set. In the raw dataset, what I'll do is I'll change the rating for the 0 movie I'll decrease it. I'll change it to 5.2. And once the scheduler runs and cleans the dataset all over again, we will see the changes here. Okay, so I have changed the value, and the clean data is also produced. So here we'll click on refresh. As you can see, the value of 0, the rating for 0 changed to 5.2. It was earlier 9.2. Now it is 5.2. So that verifies the pipeline and it shows us that it's working fine. Okay, so now that the practical part is completed, we'll proceed with creating the, not creating that, but going through the actual pipeline and leveraging it into our actual project. It's very similar to the sample pipeline that we created in the practical part. Just that the data sheets and the number of URLs that we need to paste in the dashboard has changed. Other than that, everything is very similar. We are using the same Docker container, same Apache Airflow configurations, and the same Azure configurations as well. So right now, what we have is the data that we got from the company, US pathway data sheet. It has multiple subsheets. For example, it has campaign performance sheet as a separate sheet, leads generated, phone metrics, and etc. So once this US pathway.xlsx is fed to our model, the model divides the Excel data into various sheets, and those sheets go through their unique cleaning functions, and they are scheduled with the help of Apache Airflow. And then they also get uploaded in the Azure Data Lake Gen 2. And from there, similarly, as we did in the practical part, we copy the SAS URL and we paste it in the dashboard. Okay, this is a main.py file inside our dashboard, similar to the practical pipeline that we created. There's not much change in this file. Instead, some of the output paths and the dataset directory, the raw data path has changed, and we have also added a few more configurations to make the actual project more, like so that you can easily debug it if you face any error. Building the absolute path for all the needed files. Dataset dir stores the actual raw data that we have. So US pathway main.xlsx consists of various sheets inside of it. For example, campaign performance, phone metrics, token speed, webinar, and etc. And so what we are trying to do here is we need to extract those sheets from the actual raw data storage and then pass those extracted sheets into their respective unique cleaning functions, and then upload the output path, upload the output file into our Azure Blob Storage. And let's take a look in the cleaning functions. So this is a file where we store all our cleaning functions similar to what we did in the practical. Now, I won't go in depth regarding what is happening with the cleaning process and the transformation process, etc., because that is not the point of this video. As you can see in this function, clean campaign performance, we are doing the same thing that we did in the practical, sample practical. We are passing the file path and then the output path, and then we have a bunch of cleaning code here. So I'm not gonna go in depth for that, but the rest is just similar to what we did in the sample project. It reads the campaign performance data from the Excel file, drops unnecessary columns, and so on, and then uploads a clean CSV file to Azure Blob Storage. And then one thing extra that we are doing in this actual project is we are logging every step so that if any error gets thrown at us, we can easily debug it. I'll show you the log file once we actually run this pipeline. And from there, we go to the final function, that is revel purification. So this function is just a main function that we are going to call in the main.py file inside our DAX folder as a Python callable. I am not running all those functions, all those cleaning functions that I have created individually, but not in a sequential manner, but instead I am running them parallelly so that the final output time is much faster. And that's why I have created multiple threads inside it. And then we are calling this function inside the main.py file here. Then we are passing the important necessary parameters, and then we are calling it as the Python calling. Also, to make sure that everything is accessible to us at a single place with just a few button clicks, I have created a GUI. Let's take a quick look at the GUI. I have created this GUI totally and completely on PyQt5 and using PySite 6. And this GUI acts as a control center for this entire project. We can query some sheets. We can take a look at the real time. You can just start and restart the Docker instance from here. We can go to the Airflow UI directly from here. We can also open the dashboards needed for our project. And then we can also generate some reports using AI. This is the flowchart for the GUI that I've created. So the GUI has 4 main components, that is open dashboards. It lets you open the dashboards that are needed for business, sales, or marketing insights with just a few button clicks. And then we have used Pandas AI for data querying with LLM. I am currently using Google Gemini, but I look forward to changing the LLM model to a local Olama instance. I'll quickly show you a practical for the Pandas AI. So let's say I want the top 5 campaigns plotted in a bar chart. I can say plot the top 5 campaigns. And then we can choose the sheet that we want to query. In my case, I'm going to choose the top campaign sheet. I haven't added more sheets because, I can add more sheets as needed. And with the help of Google Gemini, the LLM model, it has generated a matplotlib chart for us, which shows the top 5 campaigns based on their campaign scores. And we can also start the Docker instance directly from here. We'll go to our Docker app, and as you can see, the Docker instance has started successfully. And then we can go to the Airflow UI directly from here. You see the main DAG that we have created in our project. This is the main DAG. We'll just trigger it. Then we can go to our datadump.log. As you can see, the main thread has started, and phone metrics dataset cleaning also has started. The tokens paid dataset has been cleaned and also has been uploaded at the Azure Data Lake. Similarly for the Cat1 and Cat2, the campaign performance. And one thing to notice is that the phone metrics dataset is just cleaned for now, but it hasn't been uploaded yet because actually the phone metrics dataset was a very large and lengthy dataset, so it's going to take some time, like a few minutes actually. So I'll quickly skip this part. Okay, so that concludes our data engineering pipeline. What we covered in this video includes a basic introduction to what data engineering is, a sample project. We created a sample project and then we leveraged the skills learned in our sample project into our actual project. And I also showed you how to grab the SAS URL from your Azure portal and paste it in your dashboard to see the real-time changes in your visuals. So my name is Aryan Hamid, and this has been Team I Hate Syntax. And the topic of this video was Introduction to Data Engineering Pipeline and Objectives from Zero to Hero. Thank you.